In this episode, we take a calm, practical look at why modern Linux environments increasingly treat infrastructure like something you describe, track, and reproduce, rather than something you click together once and hope never changes. Even for brand new learners, it helps to know that the CompTIA Linux Plus exam does not bring up infrastructure as code, IaC, because it expects you to become a developer, but because the way systems are built and maintained has changed, and Linux administrators are expected to understand the vocabulary and the logic behind that change. The big promise is consistency, because a system that can be rebuilt from a known description is easier to secure, easier to troubleshoot, and easier to recover when something goes wrong. A second promise is accountability, because a written version description creates a trail of intent that you can review, test, and roll back. By the time we are done, you should be able to explain what IaC is, what problems it solves, and what the exam is really trying to test when it uses this term. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. One of the simplest ways to understand IaC is to picture the difference between telling a story from memory and reading a recipe that was written down and refined over time. When a system is built manually, even by a careful person, small choices and small steps tend to be forgotten, and later you cannot easily prove what was done or recreate it exactly. Those little differences add up, so two servers that were supposed to be identical slowly become different, and those differences show up as strange bugs, inconsistent performance, and security gaps. This situation is commonly called configuration drift, and it is one of the most frustrating sources of instability in real environments. IaC addresses drift by turning setup and change into a repeatable description that can be applied the same way each time. Instead of relying on someone to remember every detail, you rely on the description as the source of truth, and the human job becomes reviewing and improving that description rather than repeating the same manual steps. Another problem IaC solves is what you might call the rebuild problem, which appears whenever something breaks badly or needs to be recreated quickly. If a server is compromised, corrupted, or simply misconfigured beyond easy repair, the most reliable recovery is often to rebuild the system from a trusted baseline rather than trying to patch it in place. Manual rebuilds are slow and error-prone, especially under stress, and stress is exactly when you are most likely to make a mistake. With IaC, rebuilding becomes closer to replaying a known good plan, which reduces downtime and reduces uncertainty. This does not mean rebuilding is effortless, because you still need data backups and you still need careful secrets handling, but it does mean the infrastructure shape can be restored predictably. For exam thinking, this ties directly to concepts like resilience and repeatability, where the same configuration can be created again in a consistent way. The more you see infrastructure as something you can recreate, the more you design with recovery in mind rather than hoping recovery is never needed. A key misunderstanding beginners have is believing that IaC is only for large cloud environments, as if it has nothing to do with a smaller Linux setup. In reality, the core value appears as soon as you have more than one system, or as soon as you care about being able to reproduce a system later, even if that system is just your own lab machine. If you install packages, change service settings, add users, adjust permissions, and open network access, you are creating a configuration, and that configuration is effectively a set of security decisions. When those decisions exist only in your memory, they are hard to audit and easy to forget. When those decisions are written down as code-like definitions, they can be reviewed, compared, and improved with each change. This is why the exam frames IaC as an approach, not as a single product, because the main goal is a repeatable, reviewable way to describe infrastructure state. Once you understand that, you can explain why IaC shows up even in roles that are not purely cloud-focused. It also helps to understand that IaC usually pushes teams to think in terms of desired state rather than one-time actions. A desired state description says, this system should have these packages, these services should be configured this way, these permissions should be set, and these resources should exist with these properties. When you apply desired state repeatedly, the system converges toward that description, and unexpected changes are either corrected or surfaced as differences that require investigation. This contrasts with an action-based mindset, where you run a sequence of steps and hope the steps worked, without an easy way to confirm the final state beyond manual checks. Desired state thinking is important for security because it reduces the chance that a temporary fix becomes a permanent exception that nobody remembers to undo. It also reduces the chance that a system slowly becomes more permissive over time because each application of the desired state reasserts the intended boundaries. When the exam describes IaC, it is often pointing at this idea of state and consistency, not at any one tool's syntax. Version control is another central concept that the exam may expect you to associate with IaC, because the moment you treat infrastructure definitions as code-like files, you can track their change history the way developers track software. The security value of version control is that it creates traceability, meaning you can see what changed, who changed it, and when it changed, and you can often attach reasons and approvals to those changes. This matters because many outages and many security incidents are caused by configuration changes, and a reliable change history makes investigations faster and less emotional. Version control also supports rollback, which is the ability to return to a previous known good definition if a change causes a failure. Beginners sometimes assume rollback is only a software feature, but in practice it is a process benefit created by having a consistent, tracked definition of what the system should be. When you connect IaC to version control, you are really connecting it to disciplined change management, which is an exam-friendly theme even when it is not labeled that way. Another important idea is idempotence, which is a word that sounds intimidating but describes a simple safety property. In an idempotent approach, applying the same configuration description multiple times leads to the same end result, without causing repeated side effects or unintended changes. This is valuable because automation will be rerun, sometimes by design and sometimes because something interrupted it, and you do not want reruns to break systems or stack duplicate changes. Idempotence also helps you reason about correctness, because you can say, if the definition is right, then applying it again should simply confirm the state rather than reshaping the system unpredictably. For beginners, it is enough to understand that good IaC practices aim for repeatable outcomes, even when run repeatedly. The exam may not use the word idempotent explicitly, but it will often describe behavior that assumes it, such as ensuring a configuration can be applied consistently across many machines. When you see repeatability described as a design goal, you are seeing the heart of idempotent thinking. It is also useful to separate two broad styles of IaC that often get discussed, because the exam may hint at them through wording even if it does not demand deep detail. One style is declarative, where you describe what you want and the system figures out the steps needed to reach that state. The other style is imperative, where you specify the steps to take in order, more like a script that must be followed. Declarative approaches tend to align well with desired state and idempotence, because they focus on end conditions and can adapt steps based on current reality. Imperative approaches can be easier to understand at first because they read like instructions, but they can be more fragile if the environment differs from what the steps assume. This is not about one being always better, because different problems call for different methods, but it is about understanding what the exam means when it describes defining state versus running tasks. If you can explain the difference in plain language, you will be able to interpret many IaC questions that are really asking whether you recognize the benefits of describing intent versus repeating manual procedures. Security concerns are woven into IaC even when people do not call it security, because any infrastructure definition includes decisions about access, exposure, and trust. If you describe firewall behavior, service listening interfaces, user accounts, or file permissions, you are describing security boundaries. If you describe storage and backups, you are describing confidentiality and availability decisions. This is why IaC can improve security posture, because security controls become part of a repeatable baseline rather than a collection of one-off tweaks. At the same time, IaC can create new risks if it is handled carelessly, especially around secrets like passwords, keys, and tokens. Beginners sometimes assume that if something is in code, it is safe. But code is often widely accessible within a team, copied into pipelines, or stored in repositories, so secrets need deliberate handling methods that avoid accidental exposure. The exam may describe this indirectly by emphasizing safe handling of credentials and configuration data. And the important concept is that automation increases both speed and blast radius. A disciplined IaC approach tries to increase speed while also increasing safety through review, testing, and careful secrets management. Testing is another exam-relevant theme because infrastructure that is defined can also be checked, and checks reduce surprises. When you have a written description, you can validate it for syntax, you can review it for obvious mistakes, and you can sometimes apply it in a non-production environment to see whether it produces the desired state without breaking anything. Even when you do not perform those steps on the exam, you are expected to understand the reason they exist, which is to reduce risky changes and reduce downtime. Testing in an infrastructure context often focuses on verifying that the system ends up in the expected state, that services remain available, and that security settings remain correct. This matters because a security improvement that breaks a critical service will be rolled back quickly, and that rollback may remove the security improvement permanently. IaC supports safer change because it encourages small, reviewable changes and repeated verification rather than large batches of manual edits that are hard to undo. When the exam uses terms like repeatable deployments and consistent configuration, it is often pointing at this broader practice of defining, reviewing, and validating changes. Another practical benefit of IaC is that it helps standardize environments across time, which is a subtle but powerful security advantage. Systems built today may need to be patched and maintained for years, and the people maintaining them may not be the people who built them. Without a clear definition of intended state, the next administrator is forced to infer intent from the current system, and current systems often include temporary fixes, legacy leftovers, and undocumented exceptions. With IaC, the intended state is more visible, which makes onboarding easier and reduces the chance that the system becomes dependent on tribal knowledge. It also supports consistent onboarding of new systems, so you are not reinventing naming patterns, permission models, or service layouts each time you add a server. Consistency makes monitoring easier because alerts and logs follow predictable structures, and it makes incident response faster because responders know where to look and what normal should look like. The exam framing of IaC often assumes this operational maturity, where infrastructure is treated as a managed product rather than a handcrafted artifact. It is also worth addressing the misconception that IaC removes the need for Linux fundamentals, because automation does not replace understanding, it amplifies it. If you do not understand permissions, users, services, networking, and storage, you can still write an infrastructure definition, but you may encode the wrong decisions at scale. That can create widespread insecure configurations, widespread outages, or widespread data exposure, and the speed of automation will make the problem spread faster. The safer mindset is that IaC turns Linux knowledge into repeatable practice, so the fundamentals become even more valuable because they influence every system you deploy. In exam language, this shows up when questions expect you to understand both the concept of automation and the underlying system behaviors it is automating. If a definition says a service should be enabled and listening, you still need to understand what that means for ports, firewalls, and logs. When you treat IaC as a multiplier of good judgment, you naturally approach it with care rather than as a shortcut. When the Linux Plus exam describes IaC, it often emphasizes a few repeating ideas that you can learn to recognize even when the wording changes. It will describe infrastructure definitions that are stored and reused rather than configured manually each time. It will describe consistency across systems rather than unique one-off setups. It will describe automation that can rebuild or redeploy environments rather than manual recovery that depends on memory. It may also hint at integration with broader workflows where changes are reviewed, tracked, and applied in a controlled way, even if it does not name those workflows explicitly. What matters for you is not memorizing specific product names, but being able to explain why written definitions, repeatability, and change tracking reduce risk and reduce operational confusion. If you can map an exam scenario to those concepts, you can usually identify the answer that aligns with IaC thinking. This is especially true when questions contrast manual configuration drift with controlled, version definitions that produce stable outcomes. A final concept that helps tie everything together is the idea of documentation that executes, because that phrase captures why IaC is so attractive. Traditional documentation describes what someone thinks the system looks like, but it often becomes outdated quickly, and then it becomes a liability rather than a help. IaC aims to make the documentation itself the mechanism that creates the system, which keeps the description and the reality closer together. That does not guarantee perfection, because systems can still drift and emergency changes can still happen, but it does make it easier to restore alignment by reapplying the definition and reviewing differences. This also supports audits and security reviews, because reviewers can examine the intended state directly rather than trying to reverse engineer intent from a running system. For beginners, this is a satisfying conclusion because it turns the abstract idea of IaC into a practical promise. Fewer surprises, clearer intent, and faster recovery. When you can explain IaC as executable intent that reduces drift and improves repeatability, you have captured what the exam wants you to understand. As you move forward in the series, keep the IaC overview in your mind as a way of thinking rather than as a single technology, because the later topics will often feel like implementations of the same underlying goals. Infrastructure as code, IaC, is about describing systems in a repeatable, reviewable way so that consistency is normal and drift is easier to detect and correct. It solves problems like manual inconsistency, difficult rebuilds, and unclear change history by connecting infrastructure to version definitions and by encouraging desired state thinking. Concepts like idempotence, declarative intent, and disciplined review are not just buzzwords, because they are the practical mechanics that keep automation safe and predictable. The exam describes IaC through those benefits, focusing on repeatable provisioning, consistent configuration, and controlled change rather than on the name of any specific tool. When you can speak about these ideas with clarity, you are prepared to recognize IaC questions on Linux Plus and to carry the mindset into real administrative work where reliability and security depend on consistency.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.